In today's class, we are going to discuss a very simple but basic experiment. It's called determination of paracetamol by UV spectrophotometry. The basic principle of the experiment is absorption of UV rays. Drugs which have got chromophores will absorb UV radiation, any type of radiation, because chromo means color, and by absorbing radiation only we can get color. So in this experiment also, paracetamol is the drug which has the capacity to absorb UV rays. At wavelength 257 nanometers, the absorption of light is found to be directly proportional with the concentration of paracetamol. If you go on increasing the concentration of paracetamol, and the solution of paracetamol is illuminated with a ray having 257, we'll see higher the concentration, higher will be the power of absorption. And E1% 1 cm values are given for this absorption, this capacity of absorption. And in Indian Pharmacopoeia, one of the Indian Pharmacopoeia, possibly 1985 edition, we get the value E1% 1 cm of paracetamol is 715. Those who use spectrophotometer, you know that 715 is a huge value. Our spectrophotometers do not actually display more than 1, 2, sometimes 3 optical density. We use dilute solution, and the Beer-Lambert law, which actually is the basis of spectrophotometric determination, that also shows that this law is obeyed only by the dilute solutions. So we need to dilute it. But anyway, E1% 1 cm means that if the concentration is 1%, the optical density should be 715 at a particular solvent, which is basic, sodium hydroxide. 0.1 normal is normally used, saying that this is the value. Now we are going to the procedure in GIST. You have to weigh accurately the quantity of the drug. Very little quantity, so you have to take very good precaution. Usually the method of bidifference is used. Next, you have to dilute it. That brings the question of which solvent. You have to use a solvent that is specified in the book, because the value holds true only for that solvent. We use sodium hydrochloride solution, 0.1%. 0.1 normal. Make sure that every particle has gone into solution. Then after suitable dilution, that is, the optical density range should not be more than 1, you have to measure it. So in GIST, you have to open the spectrophotometer, do baseline correction, fix the wavelength at 257, and then measure the optical density using sodium hydroxide solution of the same strength, the strength that you have used for dilution as blank and take this OD. This brings us to the final part of the experiment, that is calculation. 1% solution was used as a reference. It is the E 1% 1 cm value of 715. 1% means 1 gram in 100 ml. Very concentrated solution. And it gives a very high OD also, 715. So let's simplify that. 1 gram is 1000 milligram. This 1000 milligram is present in 100 ml. That means per ml is 10 milligram of the drug. Now whenever you have taken the OD, you use a cell. Normally we use a cell that has got a path length of 1 cm. The value given is OD, that is optical density, in passing a length of 1 cm, or when it is converted from the standard curve, will give you a value of quantity that is present in 1 ml. Now you can say the quantity can be milligram, can be gram, can be microgram, can be nanogram. How do I know how much is present in 1 ml? Well, we are going to use a standard curve. The standard curve will have concentration values of the standard solution on the x-axis, and that may be microgram, that may be nanogram per ml. So if your standard curve has got the concentration in the microgram level, when you get the concentration after dividing the OD with the slope, its unit will be microgram per ml. If the quantity is in nanogram, the unit will be in nanogram per ml. It all depends upon the unit of the standard concentration.